In this video lecture, we're going to discuss our first lecture, Introduction to Algorithm and Complexity. What is algorithm? An algorithm is a sequence of unambiguous instruction for solving a problem, for obtaining a required output for any legitimate input in a finite amount of time. So basically, algorithm is a steps or procedures that transform our input to output on a specific time. And based on our definition, these are the keywords that determine this is a good algorithm. So first, an ambiguous instruction. If say an ambiguous instruction, it should be clear, concise, easily understand by anyone. So easily implementable by anyone. Second, legitimate input. So the legitimate inputs means these are set of inputs wherein this algorithm works. Outside of it, definitely the algorithm will not work. Okay, and finite amount of time. It should give us an output based on the specification of the user based on time, not too long in giving us an output. It should be based on the time needed by the user. So another definition for algorithm based on other sources, an algorithm is a computational method for solving a problem. It is a sequence of steps that take us from the input to the output. Again, steps, procedure that converts input to output to solve problems. That is algorithm. So how could we say this algorithm is good or not? So it is based on these four criteria. So first, correctness. So the output should be the same as the desired output of the user. It should give us the correct output based on the given specification. Second criteria, finite. It should terminate. It should give us an output and stop the processing of the algorithm. Third, general. It should work for every instant of a problem. If it works with problem 1 and problem 2 is almost the same as problem 1, therefore this algorithm could be used on this problem 2 and with other problems that are alike. Then fourth, efficient. It should use few resources such as time and memory. Less time, less memory is better in processing our algorithm. So again, the criteria for determining if algorithm is good are correct, finite, general, and efficient. And these are some well-known algorithms used in different problems. So sorting, so arranging of values, searching, looking for values in a given set, shortest path in a graph, you want to determine the path going to a certain location in less cost, minimum spanning tree, primality testing, travel salesman problem, if you want to go to all location, NACSA problem, chess, Tower of Hanoi, and program termination. But there are problems wherein there is no efficient algorithm, or probably there are no algorithm at all to solve that problem. So as CS, we look for that. Okay, if there is a possibility that we could create our own algorithm that could solve those problems. So example of computational problem, sorting. So our input definitely sequence of numbers, A1 to AN. So output, we need to organize it from A1 to AN. Okay, wherein A1 is the smallest, AN is the largest. So instance, so this is our the given 53283. So how could we sort this? So we have lots of sorting algorithm that we discussed in data structure, like selection sort, instantiate sort, merge sort. So as computer scientists, we need to know which is the better optimized algorithm that we could use for this type of problem. So through analysis. Okay. So now, what are the basic issues related to algorithms? So if you have a problem, so first thing is, how could you solve that problem? So you have the initial idea. Now, how to design an algorithm for that problem? How many steps? How many levels? How many variables are you going to use? Second, how we're going to show it, how we're going to express the algorithm. Third, how we're going to prove the correctness of our algorithm. Will it give us a good result, a correct result? And fourth, how efficient is our algorithm based on theoretical and empirical analysis? And how could we optimize our algorithm? So usually, these are the problems that we are solving in our thesis that involves algorithm. So why study algorithm? So definitely as CS, this is one of our core course. We want to determine what algorithm that can be used in a certain problem, what are the good algorithm, what is the best algorithm to be implemented in a certain scenario. As computer scientists, we need to know that. Okay. So again, our two main issues in creating an algorithm related to algorithm, how to design and how efficient our algorithm is. Okay. So how do we determine how good the algorithm is aside from the first four criteria? So time efficiency, space efficiency. But here in our in our course, we're going to ignore the correctness. We're going to focus more on the time and space complexity. And for the better algorithm, we're going to determine the lower bound and optimality of a certain algorithm to say that this is better compared with the others. And these are some algorithm design techniques and strategies that we could implement in solving problems. So brute force, divide and conquer, decrease and conquer, transform and conquer, space and time trade-off with the approach, dynamic programming, iterative improvement, backtracking, and branch and bound. Some of this will be discussed in our course. So definition of each, example of each will be discussed on our other video lectures. So see you on the next video lecture. Thank you for listening, guys.